All right, guys, this is a video on the reciprocal graphs. Okay, so for today's lesson, we're going to get through the reciprocal graph of sine, cosine, and tan. And you know these names are as cosecant is going to be the reciprocal of 1 over sine of x. Okay, so we know what the sine curve looks like. This is the graph of y equals sine of x. But now we're going to graph the reciprocal graph of that. All right, so there's two ways to look at it. If you are just more comfortable with the unit circle, you can always refer to the unit circle. And what's so special about the unit circle is that you know that every single coordinate can be written as cosine sine, cosine sine, cosine sine, cosine sine. So if I'm going to graph the reciprocal function at those quadrantals, I'm focusing at just the y values because that's going to tell me about sine. And I'm just going to flip them. The reciprocal is to flip it. So if I have at 0, let me go back to this, sine of 0, we know is 0. Well, that's the same thing as 0 over 1. So what is the cosecant of 0 going to be? Well, you're going to flip this and you're going to get 1 over 0, which is undefined. On a graph, undefined always graphs out to be a vertical asymptote. So you're going to get a vertical asymptote at 0. That now I go on and I look at pi over 2. Sine of pi over 2, well, that's just equal to 1, which is the same thing as 1 over 1. If I flip that, it stays 1. So cosecant of pi over 2 stays 1. So at pi over 2, I'm going to make this be 1. I'm going to keep it there. Okay. So now I go back to pi, go next on to pi, and I'm flipping 0. So again, I'm going to see an undefined value at pi. Therefore, you're going to have a vertical asymptote. At 3 pi over 2, you see that sine is equal to negative 1. So sine of 3 pi over 2, that should be sine, is equal to negative 1. Well, if I flip negative 1, you're going to keep negative 1. So the cosecant of 3 pi over 2 of the same angle will stay negative 1. So you'll go here, and this is going to be negative 1 down here. We're going to plot a point there. And back at 2 pi, it's the same thing. So it's going to be undefined because we're flipping that value 0. All right. So as you see, I don't have much of a curve, but I have a shell. And I see that cosecant, very similar to tan, has asymptotes. We didn't have any asymptotes in sine and cosine. I personally don't like to refer to the unit circle. I personally like to look at the graph of the sine curve that I'm super comfortable with. And right then and there, you see that any x-intercept, the original function, has values of 0. So we know that if we take the reciprocal, that's going to give us asymptotes on, if I start to graph, the cosecant graph. So if I start in green, just saying I want to find my cosecant graph using the sine curve as a guide instead of the unit circle, to me it's easier. I go to all the x-intercepts, and wherever I see an x-intercept, I know that value is equal to 0. So when you flip it, you'll get an undefined, you'll get an asymptote. So far that matches. I know that at pi over 2, it's 1, and so when I flip that, it's going to stay 1. And at 3 pi over 2, it's negative 1, and it's going to stay as it does here. So now let's talk about creating a curve. Let's talk about what's happening between 0 and pi over 2. Well, here, if I had to guess what this value is right now on the sine curve, I would say at a half, right, at a sine of, let's say, sine of, let's say, 45 is somewhere in the half range, right? Well, if I flip this value, you flip 1/2, you're going to get 2 over 1. So I'm going at this value going to be higher. I'm going to be somewhere up here. All right, because instead of 1/2, I'm going to have 2 over 1. And the same idea here, right? Some value here, I'm going to be up here. And what you end up drawing is what it looks like, a parabola, all right, where your minimum is 1. All right, now I continue and I go, well, what's the case over here? If I want to graph what I think the value of this graph is going to be, I'm like, well, I'll look at the original function. At the original function, the value between pi and 3 pi over 2, I could say is negative 1/2, right? So because this is negative 1, well, if I flip negative 1/2, I'm now at negative 2, so I'm somewhere down here. And I'm somewhere for this same value, negative 1/2 is now going, reciprocal is going to be negative 2. So I end up graphing that looks like a parabola, but now going the other direction. And as we know, these trigonometric functions are cyclical. Okay, so we're going to continue the pattern backwards. So if I continue this pattern backwards, I'm looking at when my asymptote's happening, at 0, then at pi, then at 2 pi. So I know going backwards, my next asymptote should be pi units away. So I'm at negative pi, and then negative 2 pi. And then I can go ahead and say, well, where would, at negative pi over 2, the point be? And I see that it's up high, then down low. So going backward, it's going to be up high, then down low, so it can follow. Or you could just go ahead and extend this and do exactly what we did to the right-hand side to the left-hand side, but I'm going to tell you it's going to be down to negative 1. And if it's down here, then my other two values will create this parabola going downward. And I'm sure you've guessed by now, at negative 3 pi over 2, you'll be at 1. And it's going to look like so. So this is the graph of the cosecant graph. All right, and the biggest thing that we ever ask you, it's not really referenced too much in AP Calc, but what you would be responsible for knowing is recognizing it. And when I recognize it, I want you to pay close attention to where those asymptotes are occurring, okay? So where those red dotted lines are occurring, because what you're going to soon find out is that the other functions, the other reciprocal functions, also have asymptotes, and they look super similar, but they're at different values. So this asymptote's occurring at 0. This one's occurring at pi and 2 pi. And the other piece that you need to remember is, be comfortable with identifying the domain and the range, which we're about to do. But what I would tell you is that it's so much easier in my head to go to the graph of sine curve and just envision flipping over all these y values, all your output, and creating the cosecant curve. Because I personally forget where my asymptotes occur. So I just look for those x-intercepts, and wherever those x-intercepts are, I go there and I create, sorry, I should be in green, I create my vertical asymptotes there. Okay, and then I go ahead and take my 1 value and my negative 1 value and plot them and just flip this curve. It's going the other way. Okay, so domain. This looks very similar to the tan graph in the sense that I have some interruptions in my domain, so I cannot say it's all real numbers, but I'm trying to find the pattern. So here I have an asymptote at 0, at pi, at 2 pi. I would believe the next one would be 3 pi, 4 pi, 5 pi. So how do we address the domain? We're going to say that the domain's all real numbers, except for, now it's any integer, 0, 1, 2, 3, 4. So any integer, which is positive or negative whole numbers. So I'm going to say n pi, except for n pi. That's where n is equal to an integer. That is the domain of the cosecant curve, okay? It's all real numbers except for n pi, okay? Now the range is interesting. It's not all real numbers. I say it doesn't ever stop going up, but it does stop going down at, what's this value that we said? This value was 1. And then it picks up at negative 1. So if you notice, there's nothing happening between negative 1 and 1. So your range is y is less than or equal to negative 1, or y is greater than or equal to 1. All right, in interval notation, you would write it as -1 to negative infinity to -1 inclusive with the union sign to 1 to positive infinity. All right, again, you are required to identify the graph. Like this would be, if how would you ever be tested on this? You would have to be able to match this graph with the correct equation. And that solely is what I keep my eye on, is where those vertical asymptotes are occurring. And you are responsible to understand or state the domain and the range of the cosecant curve. But that's all with cosecant. Now we're going to move on to the secant graph, all right? So the big important piece here is understanding what function goes with what. So here, knowing that, cosecant, well, that's the reciprocal of cosine. All right, so basically you're flipping the cosine values. So again, I'm looking at this. Now you could go ahead and use a unit circle like we did, but I'm just going to concentrate on the cosine curve that I know I'm very comfortable with. All right, anywhere I see an intercept, I know the cosine at those values are 0. So I know that if I flip 0, I take the reciprocal of 0, I'm going to have an undefined value, which means on a graph, I'm going to see a vertical asymptote. So here you have pi over 2. This is pi over 2 right here. I'm going to draw a vertical asymptote because I just look for those intercepts and draw the vertical lines there. And go, I do have another one at 3 pi over 2. All right, following suit, I see that it's going to be pi units over. So I know the next one's going to occur here, and the next one going this way here. All right, now I want to think about those 1 values and those -1 values. Here at 0, your cosine of 0 is 1. If I flip that, it's going to stay 1. So at secant of 0, it's going to be 1. And then at secant of pi, it's going to stay -1. All right, now what's happening in between? Again, you're basically reflecting, okay? Not reflecting, sorry. Reciprocal, it's bouncing up. So if it was going like this down, it's going to go up, right? So from here to here, it's going to go up. And then this way, it's going to go this function, right? It's just taking those values, let's say that 1/2, and now making it -2 down here. So this is your graph, looking a lot like the cosecant graph, but what's the major difference? The major difference is the fact that oops, I put that point in the wrong spot. The fact that those asymptotes are occurring at different spots. Okay, so let's go and finish this graph. It's looking like cosecant, so the pattern stays, all right? Here, this is a 1 value, so at 2 pi, it's 1. And again, it's just going, you see this value is going to almost like it's flipping it upside down. It's going like this. And then here, it's going to follow suit, so I know this is going to go -1. So super similar. And here, it's going to be 1, but like that. Super similar to cosecant, but it is secant. And the big difference here is your asymptotes. What you'll notice, your asymptotes and your domain. Your range is the same. Your range is going to be, there's nothing going on between -1 and 1. So y is less than -1 or equal to, or y is greater than or equal to 1. So that stayed the same. And again, we could write it as -infinity to -1 bracket 1 to infinity. Sorry, that's getting cut off. I'm going to stop this video and finish the lesson on the next video.